Good morning. How you do? Today I will explain how the map range node works through dissolving a donut. So let's begin. Click A to select all, then X to delete everything. Then we're gonna add a donut through going to mesh, shift A, mesh, torus, add torus. This increase the minor radius a bit just to make it look like a proper donut. And let's increase it's not very necessary to increase the minor segments, but let's do it anyway. I'm gonna rotate it on the Y by 90 degrees. Or no, I should rotate it by the X by 90 degrees. Because I want it to dissolve along the Y axis, like this, in this direction. So we're going also to apply the rotation because if we don't do that, it will count. I think it's gonna count the upwards direction, the z-axis as the y-axis, according to the local rotation of the object. So let's pull this up. Go to Geometry Node Editor. Click on New. Go over here. We're not going to actually dissolve like this donut. We're going to instantiate a bunch of instances on this donut, and afterwards we're going to dissolve them. Let's go grab on the X, and afterwards we're going to instance on points. The type of instance I want is an icosphere. You can have any kind of sphere. But I want an icosphere. Let's make this 0.01. Not too small. But still, I haven't distributed points on this donut. No, I haven't. I should distribute points on the donut because that's more optimal, frankly, by going to point, distribute points on faces. These are two little points. Make them 1,000. They're a bit small, I guess. So let's bump it up to 3. Too big. 1, 5. Good. Now the way I want this donut to be dissolved is by using geometry proximity, just to be able to explain the map range node a bit better than usual. Now I'm gonna add a plane, and the closer this plane is to the point, the how to say it, the more the displacement on the Y is going to happen, and the more the noise texture which I'm going to use to add some little more displacements, like the donut is going away with the wind, stuff like that is going to increase too. And also, the more they go on the Y, the smaller the instances are going to become until they are invisible. So I'm going to scale it on the X, just so everything is touching the plane. Let's go apply the scale. It's not very necessary to do that, but I like to do that just in case. Now we going to first of all place them on the Y according to how close this plane is to the donut. Now we're going to pull the plane all the way over here. Set this to the relative. Go to geometry, geometry proximity, and then we're gonna pull out the distance. But first of all, let's pull out the set position. Put this to the offset, like that. That looks good. Now, when we grab this, you're gonna see some weird things going on around here. This isn't what we want to happen. We want the instances to go on the Y, not to go in all of the directions. So we're going to pull out, go to vector, and combine X, Y, Z. So it moves only along the Y-axis, like this. Grab on the Z, yeah. like this, moves along the y-axis. Now this looks really good, but the problem is the more I bring it up, the more further away it goes. How to say it, it still goes. Now that's not what I want. I don't want it to keep going the more this keeps on going. And furthermore, I don't want to affect all the donuts. I just want to affect a small amount of it along the range like this. I just want to affect like this area, and everything else is supposed to stay normal. So let me Control Z this W. Let me go in and set this back to 0. That's where the map range node comes in. So we're going to Utilities, Map Range. Now, as you can see, it's already working on limiting the radius of effect of the proximity to the plane. But still, there's something wrong. I want the the closest parts to get displaced, not the furthest parts to get displaced. So I want to flip these. I'm gonna put this to 1. I'm gonna put this to 0. This is how it works. Neat, eh? Now I want this area of effect to be way smaller than that. So here's what I'm going to do. I'm going to decrease this. Now the way the map range node works is somewhat similar to the what to call it, the what is it, color ramp node, where it sets the color according to the values, like this. Like all the way to 1, it goes to 1. All the way at 0, it goes to black. Now in Blender, I don't know about other softwares, uh, wh white is 1 and black is 0. Now you can also flip them, make the 0 1 and then the black is, and then the 1 0, like that. There are other uses for the map range node. Allow me to demonstrate. Shift A, let's add another plane over here. Let's click on forward slash to isolate this plane. Go to shading. Let's forward slash here too. Add a new material to this one. And then we're going to use a texture. Let's use first a noise texture. Color, no, not the color. I want the factor. The factor here. Now let's say I want on this noise texture the black parts to be blacker. What should I do is pull out the color ramp. Wait a minute, no, converter, color ramp, and then pull on this. Let's say I want to flip the values. I want this to be white and this to be black. It's easy, just flip this too. There it is, as easy as pie. This is how the color ramp works, and you can also use it to add colors and stuff like that, make it a bit more colorful. And you can also add more control points to it. Like I want this part to be blue. You can mess around with what kind of equation it uses to factor in these things, like place spline, ease, cardinal. I most of the time use B-spline though, and you can also use constant. Constant is very helpful most of the time if you want to do something funky like this, which looks like a lot of fun, frankly. Yeah, looks really good. But there are other textures like let's get rid of this, like the Musgrave texture. Now the Musgrave texture has this height output. And if we put go to converter, math greater than, let's say less than, let's put this to less than better. This will show you that there are parts that go below -1, below the 0, because it goes below to the minus values. Now the problem with the the color ramp, it can't go to negative values at all. It can't go there. So what you have to do is just you think I need to just live with it? No, you don't have to just live with it. You can pull out a map range node. Let me get rid of this. Control X, converter map range node, and then you can set it like this. Let's say I don't know where the Musgrave texture goes all the way down to. Let's say -1, I guess. Yeah. Now it all goes down. Now what this does is that if the value is -1 or below, it's going to be 0. And if the value is 1 or higher, it goes to 1. It becomes 1. And what's between -1 and 1 is going to linearly, as set in here, linearly go all the way to 1 in a linear fashion, like a constant line like this, not like this or this. You can actually make it smoother by using smooth step and smoother step and all that stuff. But I'm going with linear for now. And through that you can actually make use of it. Wait a minute, must be better colors to it. B-spline. Yeah. You can actually get more control in your texture of your texture. That's why it's very helpful, the map range node. It can really help you. And you can even increase this so it goes all the way to 10 when it reaches 1. You see, it just gives you a lot of control over what you have. Now let's go back to our example over there. Let's get rid of this plane X. Click on / again, and let's continue on dissolving this donut. Now we set it this way to what to do, yeah, to displace these particles all the way to the Y. So the closer this is, the plane, to the instances, let's say, the more they go to the Y. And you can increase that by going all the way over here, going to utilities, math, instead of add, use multiply. And let's say we want it to go all the way to 5 meters, something like that. Now that's looking good, but there's a problem. They look a bit too linear to me. So what am I gonna do is use smooth step, which doesn't smooth it out a lot more. Smoother step doesn't do that either. So what am I going to use is the following. Grab on the X. I'm going to use a float curve, which allows it to be even less linear, like this. You see, that's what I want. You see that? It kind of looks like the curve over here, if you put it like that. Right, way like that. And the thing with the float curve is, I think it just returns the maximum value to be at 1. So you can't just put the multiply back here and then add the float curve and expect everything to work the way you want it to. You have to multiply it afterwards like that. But anyway, I think that's good. What's also useful about the float curve is you don't want it to go all the way to 1. Let's mute this. Let's say you want to make some funky look to it, like here, like this. You see that? Now that looks really neat. Now don't calculate this as all 1. This is 1. The plane is here in the middle. These instances are equally distant from it as these instances over here. Look at this. So you see the same shape here occurred over here. So that's what's so useful about the float curve too. So let's drag this over here, go to this one, click on X over here, go to this one, click on X over here, and then do it like that, and here we go. Hmm, let's get rid of this color ramp. Let's bring back the multiply. That's looking good. Now, what are we going to do? Here's our setup for displacing them on the Y. Now I want to add a noise texture to it. I'm gonna make everything separate. Shift D, set position. Copy these two again, I don't know, just to make it a bit more neat, more tidy. Now we're going to set the displacement using a noise texture. Texture, noise, put the color in the offset. Now, as you can see, it moves a bit like in this direction. Now, we don't want that to happen. That always happens with the noise texture. So you gotta go to vector math and the minus zero point 0.5 while it's at add. Subtract the zero point 0.5 from all of the axes, and then you're gonna have it centered around that. And then Shift D adds a scale just so we can control all of them at once. Now, I don't think that the scale is the same thing as using a math multiply, because they're not the same thing. A math multiply is gonna return just one float, not a vector like this one. And that float is gonna be copied on all of the axes, x, y, and z. So it's going to go like this, you see. Increase this way, in this direction like that. Now we've done this. Now we need to influence it like that. So the closer they are, as you can see, these instances are getting farther away, so they are more influenced by the noise texture. So the closer they are, the less they are influenced, because the distance decreases, thus the scale decreases. Grab it over here. So we're gonna use a map range node, so I can make the scale of it increase like that. This looks good actually. I actually nailed it right over here. Yeah, looks really good. But as you can see, these instances that are getting further away are not affected the way I want them to. Like they display when they displace on the Y too much, they get further and further away from the plane. So as a result of it, the noise texture doesn't affect them that much. So we're going to do the same thing over here. We're going to go input position. Is this how I did it? Yeah, this is how I did it. We're gonna go to vector and separate x, y, z. We're going to going to copy paste this whole thing over all over again. And this geometry. Okay, this looks stupid. And then we're gonna grab it all the way over to here. I'm gonna put the y to the scale. Now, as you can see at the 0 point, the instances aren't very displaced, but the further they go on the negative y and the positive y, the more they are displaced. Now, I don't want that, so here's another use for the map range node right over here. I'm gonna pull this out, Shift D. Now, this doesn't look like it's working well. So what we're gonna do, we want it to start like, see this block? This block has to be 1 meter and all the way to 1, 2, 3, 4, 5, 6, 6 meters. So I'm going to put it for the from max value to 6, and the from min value, I'm going to set it like this. Now I want this one not to be 1, I want this to be 0, and this I want it to be 1. So the more like this. Let's bring these two together closer. And as you can see, there's something like a small point over here that where the noise texture is not offsetting anything. That point over here, I just set it like that by using the from min value. It's just like the what is called like the handle on the color ramp. But what's so useful about it is that you can go to the negative values about it or any other value you want, and you can go and from max can go all the way up to wherever you want it to go. So that's very handy. So let me go to utilities, math, because I want it to be a bit more chaotic than that. Don't add multiply for God's sake. Yeah. That's what I want. But I don't like how these some of these are, as you can see, when the displacement increases, some of them are going back on the y-axis. So I'm going to go over here and add a multiply node. Shift D, multiply. Where is it? Multiply over here. And I'm going to set these to 1, all of them. And but the y, which is the middle one, like this is x, y, and z, I want it to be 0, so they don't displace on the y-axis, only on the x and on the z-axis. That's all I want. Now this looks a bit neat. Now let me go here to the noise texture. Both of these noise textures. Ah, crap. I should have used the same noise texture for all of them. Wait a minute. Let me get rid of this. Control X, and then pull this all the way out from this. Add all the way to here to the scale. So they're influenced by the same texture, so there's no disparities between them or anything like that. Let me make it smaller a bit, 2.5. Now they look like they are disintegrating. Now we're gonna add another one of these things right here because we want these to decrease the more they go on the Y, decrease in scale. So they look, when they turn into 0, when their scale is 0, it looks like they just disappeared in the wind. Let me grab this here and this is just to show you the effect that we just made right now. This is the effect we just made. Now I need to decrease this just so these can stop being a bit more chaotic. Multiply the Z a bit and the X a bit. Grab on the Z. Let me put a driver on it. Hash frame over 100. Still. This is weird. Now I don't want the X to be bit too chaotic. The Z is a bit too chaotic still. Hmm. Ah, well, it doesn't matter because I want them to disappear after that point, right over here. So I'm going to add, go Shift A instances, scale instances, and then pull out these three. Shift D, scale, put it over here. Now, as we set it up in here, the scale of the noise texture is supposed to be less the least over here. You see? So we don't want that. We want it to decrease as long while it's going over here. So we're gonna set this the same way it was, but we're gonna set this 1 to 1 and then set this to 0. Now they disappear after a distance. And you can decrease that to make them disappear right over here. Now this looks really neat, doesn't it? Yeah, this is it for the tutorial. Let me add something to it to make it look a bit nice. Let me make this invisible. Now let's say that we want the whole donut to disappear and then reappear. So what are we supposed to do here? Let me go delete the driver on this one. Delete the drivers. 0. Let me just make a quick solution for it. I'm going to edit mode, Shift D, Z, a bit on the Z axis, and then Shift R. Ah, well, I haven't optimized it to the best. I'm gonna have to fix it right now. Don't worry, I'm gonna fix it. But let's make it taller than our donut. So we're gonna keep on holding Shift R. Shift R repeats the previous process you made. Let's set the origin to the geometry, let's say. Grab on the Z. This is how we can make our donut entirely disappear. Ah, crap. Shift D, Z a bit more. Shift R. Doesn't matter that they're spaced out even more than these. Set geometry. Not the 3D cursor, to geometry. Set origin to geometry. Now this is looking not very well over here. So I'm going to make them. So I want them to travel a bit further. This like this. Now I'm going to go over here. Add a simple animation to it. Let's do a horizontal split over here. Go to where is it? Timeline. Let's go to frame one. Now let's press I on this transform thing. You can do it in this window too, but I like it doing here because it's faster. And then on the 250th frame, I'm gonna grab it on the Z till it all disappears. Or grab it on the Z till it comes back. No, it's gonna be too short. I want it to go very slow. Uh, I. There's our disintegrating donut. Let me hide this. Looks neat, eh? I hope this going to help you with understanding the map range node. It's a bit of a rushed video because I've been planning to do it since a very long time, frankly, and I got very frustrated with it. So I hope this helped you with understanding the map range node. We had like four instances where we needed to use it. So I hope these instances of where we used it have helped you a lot with understanding it because it's a very powerful tool. But the problem is not very much well explained. Like I had to understand it on my own while messing around with it, and afterwards I came up with the idea of the disintegrating donut. Now I must bid you all farewell and have a happy blending.